Well, question 1.1.4 says x minus 3 in the brackets times 2 minus x in the brackets. So I'm going to write the question here. 1.1.4 says x minus 3 and then 2 minus x greater than 0. All right, this is a case of inequality, which is different than an equation. Unlike equations, inequality solutions are not fixed numbers. They are an interval over a certain interval, okay? So we are required to find what we call the critical values, okay? That will determine the boundaries of each interval. So now here I'm gonna write critical values. The critical values. It is where we're going to assume that x minus 3 and then 2 minus x were equal to 0. Now, according to the law that says, the property that says a times b equal to 0, this implies that a equal to 0 or b equal to 0. So we're going to set x minus 3 equal to 0 or 2 minus x is equal to 0. Over here, if I move the 3 on the other side of the equal sign, x will be equal to 3, or if I move the x over, that makes x is equal to 2. Now we're going to draw the number line, and then where I will place in the values of 3 and 2, but I need to put it in ascending order, okay, in the number line. So there are like 2 over here and then 3 there. I cannot switch the order because in a number line, it must be in ascending order. And then the fact that the symbol over here was greater than 0, okay? I say it's an inequality because of that symbol. We will put an open circle over here, okay? By 2, it's like an open circle. By 3, also an open circle, to say that they're not part of the boundary, part of the interval. So we have like split the number line into 3 intervals. From negative infinity to 2, and then between 2 and 3, and then from 3 to positive infinity. Now we need to find the signs of the inequality in each interval. Now let's check the sign of the inequality in this interval here. Okay, I'm gonna pick up any number in this interval from negative infinity to 0, any number. When I say any number, I prefer to check 0, okay? To pick up a number like 0. Let's say 0 is somewhere there. So I'm going to sub in the value of 0 for x. I'm going to sub 0 for x, and then 0 for x, and then check. Now, 0 minus 3 will be negative 3, and then 2 minus 0 will be just 2. So the product negative 3 times 2 will be negative 6. Therefore, in this interval here, from negative infinity to 2, the interval is negative. Put my negative sign there. Now I'll move on. Let's just erase this. And that also. Now let's see, in this interval between 2 and 3, I want to take a number like 2,5. Okay, I'm going to sub 2,5 for x and 2,5 for x. You know, 2,5 minus 3 is negative 0.5. And then 2 minus 2,5 is also negative 0.5. And then the product here is more than 0, meaning positive. So therefore, in this interval between 2 and 3, the solution is positive. And then I'm going to look also on the other interval from negative 3. Let me erase this. From negative 3 to positive infinity, I'm going to take any number, any random number here. Let's take a number like 4. So if I sub 4 for x, and then 4 for x there, and then you see that you have 1 times negative 2, and then this is lesser than this. So this is negative. So meaning in this interval, the solution is negative. But we want the solution that is positive, as we can see it's there, positive over here. we want a solution that is more than 0. So therefore, we will say, we can answer our question by saying that, therefore, the solution is between 2 and 3. So we write 2 is lesser than x, lesser than 3. This is the solution of the inequality. Thank you.